Now in this example, we're going to do the exact same thing we did in the last video. We're going to find the least common multiple of 12, 15, 18, and 20, and we're going to use the prime factorization method. So the first thing we're going to do is write out the prime factorization of each one of these numbers. So I'm going to have to do a tree for every one. So 12 would be 2 times 6. 6 would be 2 times 3. Now 15. 15 would be 3 times 5, and those now are both prime. 18 would be 2 times 9. 9 would be 3 times 3, and now we're done with that one. 20 would be 2 times 10, and 10 would be 2 times 5, and now we're done with that one. So remember, our first step, I guess you should say, would be to write out the prime factorization of each number. Now our next step is to write those out neatly. So for 12, that was 2 times 2 times 3. For 15, it was 3 times 5. For 18, it was 2 times 3 times 3. I'm not writing that out very neatly. And now for 20, it would be 2 times 2 times 5. Now our LCM, we're going to use every single one of our prime factors. We have some 2's, some 3's, and some 5's. So I'm going to write those down. And now I'm going to go back and I'm going to look for the most times it appears. So for the 2's, we've got 2 of them, none of them, 1 of them, and 2 of them. So the most times that it appeared in any factorization was 2 times. So we're going to use 2 squared. Now we go to our 3's. We have 1 of them, 1, 2 of them, none of them. So the most that we talked about there was 2 of them. So we're going to use 3 squared. Now for our 5's. We have none of them, 1 of them, none of them, 1 of them. So the most times it appeared in any factorization was 1 time. And now we simplify. 2 squared means 2 times 2, which would be 4. 3 squared means 3 times 3, which would be 9. And 5 to the first is just 5. So now we have 4 times 9, which would be 36, times 5, which is 180. So our least common multiple for all 4 of those numbers is 180. Now we could have gotten the exact same thing if we had written out all of our multiples, but we would have had to write out quite a bit of multiples to get 12. So it's for the multiples of 12, rather, I should say. So this way actually was a little bit easier, especially because we were working with 4 numbers.